Welcome. My name is Miss Michelle Lopez, and I'm going to be going over the Unit 9 Circles practice test with you. So this is our first question, question 1. It says, given circle C. Remember that on the test and the SOL, another way to show that it's a circle is a little circle with a dot in it, and then C. And angle B is equal to 35 degrees. Find the measure of ACD. So the advice I give 99% of the time is plug it in. So I'm going to say angle B is 35 degrees. What is ACD? So we have angle B is 35. And they're asking us for the arc. So let me highlight it. Or they're asking us for the angle A to C to D. So that's this angle. Okay, let's figure this out. So if this inscribed angle, angle B, is 35 degrees, this is our inscribed angle, we know that the arc that it inscribes, this arc right here, is going to be double that. So what we do is we double 35, we get 70. So we can see that this arc in green is 70 degrees. Now, I want you guys to see that there is a half circle here. So let me try to highlight this half circle. We know that half of a circle equals 180 degrees. So 70 plus this arc, A to D, has to equal 180 degrees. So what we're going to do is we're going to take 180, we're going to subtract 70, and that is going to be our arc length. So that's going to give us 110. Now an inscribed angle is half of the arc, but we don't have an inscribed angle this time. They're asking us for A to C to D, which is this angle right here, angle C, and we know that is the exact same as the arc. So if the angle is using the center of the circle, then we're going to say it's the same angle as the arc. So it's going to be B, 110. Alrighty, let's go to number 2. Mr. Patrick installed a new rotating sprinkler in his lawn. Okay, for this one, they're giving you that the radius is 10 feet, so they have it plugged in for you. They're giving you that the degree is 100 degrees, our sector is 100 degrees, and what they're asking us for is how many square feet, right? That's another word for what is the area. How many square feet of lawn can be watered by the sprinkler? So we need the area sector formula. So the area sector formula is the area of the sector divided by the area of a circle, which is pi r squared, is equal to the degree of the sector over the degree of the circle, which is 360. So you're going to need to know this for your test. So remember, area of sector divided by area of circle, degree of sector divided by degree of circle. And we're going to plug things in now. So we have area of sector, that's what they're asking us for. So that's going to be our x. And then we have pi. What is my radius? It tells us that our radius is 10 feet, right? So we have 10, and we're supposed to square it. It says pi r squared is equal to the degree of my sector. It tells us is 100 degrees, and then divided by 360. So whenever we have two proportions or two fractions on either side, on both sides of the equality sign, we're going to cross multiply. So I'm going to multiply x times 360, which is 360 times x. And then I'm going to multiply the other side, which is 100 times pi times, well, 10 squared is also 100. So 100 times pi times 100, plug that into your calculators. So I did that. I plugged 100 times pi times 10 squared, or 100, into my calculator, and I got 31415.9, okay? And now all I'm going to do is I'm going to solve for x, right? So I'm going to divide by 360. Divide by that 360. Get rid of it. We don't need it anymore. So we have the 31415.9. Divide your answer divided by 360, and we're going to get x is equal to 87.26, right? So we know which one is the answer. Let's go to the next question. Number 3, it says in circle Q, which is the value of x? Alrighty, so we know circle Q is our circle, and we have an inscribed angle because we can pull it back and it's actually and is touching our angle, our circle. So 5x is an inscribed angle, so we know that it's half of whatever the arc it inscribes. So let's look at this arc. What do we know about this arc? MPQ or MPO is half of a circle. So we know that the arc is going to be 180 degrees, right? Half of a circle is 180 degrees. So 360 divided by 2 is 180. Now we know that the inscribed arc is half of that. So I'm going to say that this angle right here is going to be half of 180, which is 90. If you need to use your calculator, 180 divided by 2 is 90. But that's not really what they're asking us for. They're asking us to find x. So I'm going to have to set it equal. I'm going to say 5x is equal to 90 degrees. And then all we have to do is divide by 5. And x is equal to 18. Alrighty. Let's go to the next one. Given circle O, what is the length of the arc? So another word for length, maybe you'll see distance. So it's the same thing. Length and distance. If AB of arc AB, if AOB is 40, so A to O to B, remember the middle letter is our vertex. O is our vertex, so it's asking for this angle right here, angle O. All right, so angle O, actually it's giving us angle O. Angle O is 40. They're asking us for arc AB. So it asks you for the length of the arc. We're going to use the arc length formula, which is very similar to the area of a sector. So the arc length formula is the arc length divided by the circumference of a circle this time, which is 2 pi times the radius, is equal to the degree of our sector still, right? This doesn't change, divided by the 360, the degree of a circle. So the arc length, well, that's what they're asking us for. So again, that's going to be our x divided by, and then we're going to say 2 pi, that's not going to change, but our radius will change depending on the problem. Our radius in this problem is 9. The radius is a distance from the center to the circle, from O to A, and that's 9. So 2 pi times 9 is equal to the degree of our sector, which we have been told is 40, divided by 360. Okay. So again, I'm going to cross multiply. So I have x times 360 is 360 times x. And then I have 2 times pi times 9 times 40, which is 2261.94. All right, and then now all I have to do is one final step. I have to divide by my 360 to get rid of it, right? I want to get it, move it to the other side. So we're going to plug it in. Our answer, 2261.94 divided by the 360. That gives us x, bring it over here. So x is equal to 6.28, okay? Well, we don't really have that answer. If they had 6.28 pi, that still would not be the right answer, right? We need to multiply out our answers to find out which one gives you 6.28. I know that pi is 3.14, so that's not going to be the right one. Plug in 2 pi into your calculator. Find out if that's our answer. Plug in 9 pi into your calculator. Find out if that is 6.28. And then try 18 pi. One of them is going to be exactly 6.28. Okay? What is the measure of x, y, z? We're asked for the arc. So we're going to go from x to y to z. What is the measure of this arc? All right, in order to figure this out, what we're going to have to do is we need to know the angles of a triangle. So let's look inside of our triangle. We have a triangle right here. All right, you guys see the triangle? And we have 45 and 84. So we're going to add them up, 45 plus the 84, and we're going to see that that gives us 129. 129. But what do the angles of a triangle have to add up to be? You got it, 180, right? They have to add up to be 180. So we're going to say, well, they have to add up to be 180, but we already have 129. So if we subtract them, we're going to get 51. 51, right? So that other angle is 51. So we have an inscribed angle. This inscribed angle is 51, and we can find this arc length now, right? Because it's just double. We're going to double the inscribed angle. So we're going to say the arc length right here is 102. But that's not really what they're asking us for. So they're asking us to add up x to y to z. So let's find the other arc lengths. If this inscribed angle, angle 84, is inscribing xwy, then let's find out what xwy is. So let's make it blue. xwy is going to be 2 times your 84, right? So 84 times 2, we know that's, plug in your calculator, 168. And then I'm going to do the other one in green. Green will be good. Okay, so we're going to say 45 inscribes the z and the y. So 45 is our inscribed angle. We're going to double it to get our arc. So 45 times 2, that's 90. And then all we have to do is add them up. And we're asked for x to y to z. So we're going to say 168 plus 90. And if you plug that into your calculator, that'll give you the measure of x to y to z, right? Let's go down. Number 6. This is in the diagram, if angle P to O to R, this angle right here, P to O to R is this angle right here, is a central angle. So that means it involves the center. It's using the center for its vertex. And the measure of POR is 70. So P to O to R, this is 70 degrees. What is P to S to R? So we're asked for this angle. So let's talk about the central angle. If the central angle, if we're using the center of the circle, is 70 degrees, then that means that the arc it intercepts is also 70 degrees. So the arc PR, P to R, the arc is also 70 degrees. Okay, so I'm going to put a 70 out here. But then we're asked for the inscribed angle, and we know the inscribed angle is half of my arc, but we have the same endpoints, right? We still have our endpoints at P and R. So we're going to say my inscribed angle P to S to R, the angle that they're asking us for, is half of 70. So you just take your calculator, 70 divided by 2, and that'll give you our P to S to R, which is 35 degrees. Good. Okay, well, the answer's on this side. Alrighty, number 7. If the measure of AOB, A to O to B, remember O is our vertex, it's in the middle, is 45 degrees. They plug it in for us, that's nice. In circle O, what is the measure of ACB? Well, this is the exact same problem. Yours probably won't be in the same order, but they're asking the same question. Remember, if we're using the central angle, then the angle 45 is going to be the same degree as the arc A to B. So the arc is also 45 degrees. However, we're asked for the inscribed angle. So we're asked from A to C to B. And we know that's half of 45. So you plug it in your calculator, 45 divided by 2. You guys will get the right answer, okay? go to the next question. Okay, the sum means when you add, so the sum of the arc A to B and B to C is equal to, okay, which one? So let's go in order and find out which one. So let's look at A. A is 360 minus AC. So they're asking us when we add up A to B, which is right here, and we add up B to C, which is right here, is that the same thing as saying 360 minus AC? Well, yeah, it is, right? So 360 is the whole circle. The whole circle equals 360. So 360 minus the AC, this arc right here, that'll give you ABC. That'll give you the part in red. So that'll be your right answer. All right, let's try the next one. What is the radius of the circle defined by the equation? So the radius, some people are saying, oh, it's 30. It's not 30, right? So we know that we have the equation of a circle. It's x minus h squared plus y minus k squared equals the radius squared. All right, so 30 is not the radius, 30 is the radius squared. So I'm going to make a little equation. The radius squared equals 30. So how do I find out what the radius is? Take the square root, right? So the radius is just the square root of whatever's on the right side of your equation. Radius is a square root of whatever is on the right side of the equation, which in this case is 30. So my radius is a square root of 30. It says, what is the radius of the circle? You're done. It says circle C, number 10, circle C has center -3, 1 and radius 10. Which of the following points lie on circle C? So in order to figure this out, you're going to have to make an equation of a circle. We did this on the quiz and the review for the quiz. So let's make an equation of a circle. So I wrote it on number 9. Hopefully you guys can still see it. So I'm going to have x minus, and then I'm going to use my center, and I'm going to use my x value. So my x value is -3, right? And we're going to square it, plus y minus, and then my y value for the center is +1, and then we're going to square it, is equal to, and then my radius is 10, but remember, we got to square it, right? 10 squared. Good. All right, x minus -3 is x plus 3 squared, plus y minus 1 is still y minus 1 squared equals, and then 10 squared is 100. Now what we're going to do is we're going to plug in points, and we're going to plug in the values for x and y. And if the left-hand side of the equation is equal to 100, then we know that that point lies on the circle. All right, so this time, once you get to your first question that has the point lying on the circle, you're done, right? You don't have to pick all of them. If it's a multi-select, pick more than one. So let's look at this. Let's try A. They give you 0.97. Let's see if this one is on my circle. So remember, it's always x first and then y. So 9 and then 7. 9 is my x value, 7 is my y value. So I have 9, I'm going to plug it into my formula, 9 plus 3 squared plus, and then 7 minus 1 squared. Does that equal, I'm going to put a question mark above it, does that equal 100? Let's plug into our calculators. We know that 9 plus 3, we know that's 12, but 12 squared is 144. And then we're going to have to add that to 7 minus 1 is 6, so 6 squared is 36. So we have 144 plus 36. Does that equal 100? No, that doesn't equal 100. So that means that this point is not on my circle. Let's go try the next one. So we have x plus 3, y minus 1, right? Let me write it down again. So I have x plus 3, y minus 1 equals 100. Very nice. All right, so let's try B, 5, 7. So I have I'm going to plug it in. 5 plus 3, 7 minus 1. Does that equal 100? Put a question mark above it. We're not sure yet. So 5 plus 3 is 8. 8 squared is 64. I'm going to put over here 64. And then 7 minus 1 is 6. 6 squared is 36. Does that equal 100? Oh, 100. Okay, so add them up. What is 64 plus 36? Right, that's 100. So we're going to say this part right here was 64. And we're going to say, yeah, that's 100 equals 100. Since it is true, put a little check mark by it. It's true. So that's your answer. That's the point that is definitely on your circle. Okay, make sure you plug them in correctly and you have the right signs. Okay, you're not saying the negative when it's not. It says a circle has diameter AB, which is the equation of a circle. So when it gives you the diameter, you're going to have to use two formulas. Remember, you're going to need the distance formula and the midpoint formula. So let's do the distance formula on the side. We don't have too much room. So the distance formula is, we're going to take our x's. I'm going to start with -2, right? So I'm going to say -2 minus -4 squared plus, and then we're going to take our y's, 1, and we're going to subtract them. Remember, it's y minus y squared. So if I started with -2, I have to start with the corresponding y. I have to start with 1. So I'm going to say 1 minus 7, and I'm going to square it. Plug it into your calculator. -2 minus -4. Alrighty, so sorry I got interrupted. So we're going to solve the distance formula. We have -2 minus -4, and that's actually -2 plus 4 squared. So that's distance, if you plug that into your calculator, is going to be the square root of 40. Plug it in, make sure you guys get it right. And then that's the diameter. So in order to get the radius, we have to divide that by 2. So my radius is equal to the square root of 40 divided by 2, right? And then it says, what is the equation of the circle? So we also need the midpoint. My midpoint is, let me do it up here. My midpoint is x plus x divided by 2, and then y plus y divided by 2, right? So we have -2 plus -4, and then we have 1 plus 7. So -2 plus -4 is -6/2, which is -3. And then 1 plus 7 is 8/2, which is 4. So that's our center. Remember, we're going to always change the sign. So if we have it at -3, +4, it's actually going to be at +3, -4, right? We're always changing our sign, so it's either A or B. And then we have our radius, but remember when we plug it into our formula, it's the radius squared. So we're going to square the square root of 40/2. Alrighty, if you square the square root of 40/2, then that will give you 10. So we know what the answer is. Okay, a circle has a center and contains the point. What is the equation of the circle? So it actually gives you the center this time, so we do not have to do the midpoint formula, but we do have to use a distance formula to find the radius. And this time we don't have to divide it by 2. The radius is the distance between the center and a point on the circle, right? That's the definition of the radius. So if it has the center at 0, +5, remember we're going to change the sign, so it'll be 0 and then -5. So we have either A or B. And then use the distance formula again between 0,5 and -2,5 to find out what the radius. Remember, this is the radius squared, okay? So you pick which one. Alrighty, it says an equation of a circle is, that's our equation. What are the center and the diameter of the circle? So remember the center, like I said, we change our signs. So it's not going to be -4, it's going to be +4 and then -5, right? And then it says, what is the diameter? Well, we can find the radius because the radius is equal to the square root of 36, right? So what is my radius? Square root of 36 is 6, and then we're just going to double it to find the diameter. So the diameter is not 6, the radius is 6. and we're going to double that to find the diameter. So I think it's B. Alrighty, let's look at this. Okay, which is an equation of a circle? It says the diameter is 8 and the center is at 1, 2. So remember the center, we're always going to change the sign. If the center, they give us it's at 1, positive 2, the equation is going to be minus 1, minus 2. So it's going to be either C or D. In order to find the radius, our diameter, it says our diameter is equal to 8. Well, the radius has to be half of it. So 8 divided by 2 is 4, right? And then remember, this equation says we're going to square it. So these have to be the squared. So 4 squared is 16. In the diagram below, it says Q to P and Q to R are tangents to the circle. Okay. So if they're tangents to the circle, then we know that they meet at a 90-degree angle. So if this whole thing is 90 and this is 40, then all you have to do is subtract to find what Q to R to P is, right? Okay, this question was on the quiz. We did this question on the quiz. So remember, we're going to find the center first. So the center is actually this little dot right here, and I don't know if that's why people had problems with this one. So we're going to go over, we're always going to do the x-axis first, so we're going to go over 1, 2 units, and then we're going to worry about the y-axis. So we're going to go down 1, 2, 3, 4 units. So we're at 2, negative 4. And remember, when we plug it in the circle, it's going to change the sign. So it's going to be negative 2, positive 4. So it's either going to be C or D. And then to find the radius, we're going to find the distance from the center to the circle, and then we're going to square it to plug it in the formula. So it's going to be the one that's the radius squared, not the square root. So A, B, and C, D intersect. Let's look at what that looks like. So A, B, and C, D intersect. Find the value of x. Okay, so this one we have an equation that it says we look at the same line. Let's look at this line A to B. And we're going to multiply the segments. So 3 is on that line and x is on that line. And we're going to set it equal to the other line. So let's make that other line green. And we're going to multiply the segments, which is 4 times 6, right? All you have to do is solve for x. So we have, alrighty, it says T to W is a diameter of circle X. So, and it says that these two lines are parallel. So we know that if T to U is 25, then W to V is also 25. All right, but it forms half of a circle. So TW, this line, makes half of the circle. So we know that half of a circle is equal to 180. So we're going to have 180 minus the 25 plus 25, so that's minus 50, will give us the rest of it, which will be U to V, the rest of it. Alrighty, number 19. Almost there, guys. We have A to P is 8. And we have P to C is 4. What is the measure of A to B? So we want part of that arc. So we have this formula that says the tangent line squared. The tangent line is the one that hits the circle once. So that one is 4. So 4 squared is equal to, when you add these up, which is the 8, on the other side, let me highlight it. When you add these up, which is 8, times the outside, which is P to B, right? The outside, we don't know. It's part of 8. So let's simplify this. 4 squared is 16 plus 8x. So let's divide by 8. And we have x is equal to 16 over 8 is 2. So x is 2. So out here, this is 2. And then we know that the inside is going to be 8 minus 2, right? And we're asked for A to B. So the A to B is going to be 8 minus the 2 that's outside. And the figure shows a circle, R, P to Q, and we are given 2 of the angles. What is the measure of P to R? Okay, so all we need to do is find out what angle Q is. And we did this kind of before. They have to add up to be 180 because they're inside of a triangle. PRQ is a triangle. So add up 50 plus 60 first, and then we're going to subtract that number from 180, right? And we're going to get Q is 70. So they have to all add up to be 180. Remember, Q is an inscribed angle, so Q is half of its arc, and its intercepted arc is P to R. So we're going to double it to find P to R. Okay, so P to B and P to D intersect the circle at A and C. What is the length of P to C? We're going to do the exact same thing. So this time we don't have a tangent line, but we're going to do the same thing. So let's look at this side first. We're going to add them up first. So 5 plus 4, which is 9. And we're going to multiply it by the outside, because that's what the formula says. And the outside is 4. And that's equal to, when you add them up, so the whole thing they give us is 12. Alrighty, so we have 9 times 4 is equal to, and then we're going to add them up. We're going to add up D to P, and that's going to be, they gave us, that's 12, times the outside is C to P, this one, which we don't know what that is, so that's X. We're going to try to figure that out, right? So 9 times 4 is 36 and equals 12X, and then solve for X, and that will give you your outside, and that's, this time, that's what they're asking us for. Ready for this question? Circle C below has shaded region. So we're actually looking for the shaded region. The radius of the circle, they plugged it in for us, 6.3 inches, and they gave us the angle. So they're asking us for the shaded region. And that's the area. Look, it says area right here. So this is 87 degrees, but we actually need the shaded region's degrees. So we know that a circle is 360, and if you subtract the 87, you're going to get the shaded region's degrees is 273. Okay, and that's all you need for the formula. You need the degree and the radius. So this one is not arc length. This time it says area, so we're going to use area of a sector. So we have area is the one that we're trying to find, so that's our x divided by pi. Our radius is 6.3, and then we're going to square it. Pi r squared is equal to the degree of our sector, which is 273 divided by 360, right? If you cross multiply, you're going to solve for your x, and you're going to get the right answer. That'll be your area of your sector. Okay, which of these proportions should you use to calculate the area? So you're going to look at what we set up to figure that out. That's exactly what we set up. Question 23. C to G is best described as a... Okay, well, it's not a diameter, right? It doesn't go through the center. It's not a radius. It doesn't go through the center. So it's either a chord or a secant. A secant is a line. A chord is a line segment, and it says C to G up here. They don't have arrows on it. It's a line segment, so we're going to go with chord. This one was very interesting. So it says, this is a real world example of arc length. We're going to use our arc length formula. So what is the distance along the Ferris wheel between two consecutive seats? So I like to draw my picture, even though they gave us a little picture. I'm going to draw a picture of a Ferris wheel, and I have 30 seats. I'm not going to draw all 30 of them, but all of these little, this is the Ferris wheel, beautiful. And all these little seats are 30 seats, okay? Let's pretend they're 30 seats. So the distance between two of them. So this distance is what we're trying to find. And that's actually an arc length because a Ferris wheel is circular. And they're telling us that the radius of our Ferris wheel is 45 feet. So this is going to be 45 feet. All right, and there are 30 seats equally spaced out, which is really nice because we're going to say 360 divided by the 30 will give us the angle measurement. All right, so 360 divided by 30, that's 12, right? So that's going to be our angle measurement. So it's 12 degrees. So between two seats, that is exactly 12 degrees. So right here, this angle would be something like 12 degrees. Okay. So let's plug it into our arc length formula. So the arc length is what they're asking for. So that's going to be our x is divided by 2 pi times the radius. The radius in this one is 45. Is equal to the degree of my sector, which we just figured out was 12, divided by always 360, right? All you have to do is cross multiply. Use your calculators. In the diagram, these two are both tangents. We know that tangents to the same circle, they're both tangents and both have the same endpoint, which is right here. They meet at G, then they are equal. So let's set them equal. So we have 2x plus 3 is equal to 7x minus 12. Set them equal. Solve for x. Use the information above to find the length of f to g. So when you're done, plug it in for f to g. All right, AB is tangent to the circle. That means that it meets at a right angle. So A to B, this is our right angle right here, right? Find the value of x. So when we have a triangle and it's a right triangle, we use the Pythagorean theorem. The important part is for you to know what is the hypotenuse. That's the only thing you really need to know. The hypotenuse is always going to be opposite that right angle. So our hypotenuse is going to be 15. Right, this is on our homework. We've done this a lot. So I'm just going to start with 9. You could have started with x. So I'm going to say 9 squared plus x squared is equal to, and then I have my 15 squared. Solve for x. Plug it in your calculator. Given that the measure of arc AD is 54 and AED is 66, find BC. So AD is 54, AED is 66 minus. All right, they plugged it in for us. They want BC. So we have the formula that says this arc plus this arc divided by 2 will give us the 66. So I'm going to plug in the formula. So I'm going to say the angle, which is 66 degrees, is equal to one arc. I'm going to start with 54 plus the other arc, which we don't know what that is, dividing by 2. Always have to divide by 2. So we're saying that one arc plus the other arc divided by 2 will give us that 66, right? So this time, remember, I always like to multiply by 2 on each side of the equation to get rid of that divided by 2, get rid of the fractions. We don't really like fractions. We just multiply 66 by 2, or add it to itself, and we get 132 is equal to 54 plus x. And solve for x. In the diagram, A to B is tangent to the circle at point A, and BD intersects the circle at point C and D. What is the value of x? So we have a formula, and it says the tangent line, which is this line, squared. So we're going to say x squared is equal to, remember, we add them up first. So we're going to look at the other line now. We're going to look at 5 and 4. We're going to add them up first, which is 5 plus 4, which is 9. And then we're going to multiply that by the outside one, which is 4. Alrighty, so 9 times 4 is 36, which is really nice because x squared is equal to 36, and we can actually take the square root of it, right, and solve for x. In circle R, we have the measure of CED is 60 and AB is 80. We're going to do the exact same thing. Since they intersect, these two lines intersect in the middle of the circle, we're adding. So we're going to say 80 plus this arc. Right, so we have this arc plus the other arc, which we don't know what the angle is, divided by 2 has to equal the angle, which we're given is 60. So remember to multiply by 2 on each side. and we get 80 plus the x is equal to 120, and solve for x. Okay, this is our last question. We have angle A to B to C. What is A to B to C? So we have another formula that says if they intersect on the outside of the circle, then we're going to subtract, remember. So angle B is equal to, we have these two arcs. We're going to always say the big arc first, so we're going to pick 88, minus the small arc, which is 26 over 2. So remember to do whatever is on top first. We're going to do 88 minus 26 first, and that is 62. So I'm going to say angle B, let me change colors. So angle B is equal to 88 minus 26, I said was 62 over 2, which that is 31 degrees. Okay, and that is all we have today for circles. Thank you so much.